Okay, so I'm just trying to patch together this video. The YouTube upload rejected it because it was too long. But anyways, we're talking about quotient law, and that it's loosely connected to the one that you know for exponents, which is if you divide exponents with the same base, that it's the same thing as subtracting them here. So again, the pattern's very similar. Here's the division, here's the subtraction, and they all have the same base. So let's try using this log law. For example, we could do this here. We couldn't do log 300 without a calculator, but we could rewrite this as log 300 divided by 3. So that would be the same as log 100, which we can do without a calculator. That's 2. In the next example, that's log 5 of 250 divided by 10, and that would be log 5 of 25, which is also 2. And in the last example here, this would be log base 3 of 108 divided by 4, which is log base 3 of 27, and that's 3 cubed. Okay, so we'll try working it the other way with this log law as well. So that's if we try expanding these. So for example, we could rewrite this as log 10,000, take away log 100, and this would be 4 minus 2, so I believe that should be a 2 if we were to go and calculate that. Okay, if we did the same thing here and expanded it, it would be log base 3 of 81, take away log base 3 of 27, and again, I believe that's the 4th exponent, that's the 3rd exponent, so this should be equal to 1. And then finally, this would be log base 5 of 625, take away log base 5 of 25, so that would be 4 again, take away 2, so this would be 2. Now, in these examples, I'm not saying it would make your calculation easier to do it this way. Certainly, you know, this one here, this is just 3. It would be a lot easier if we just did the division. But again, the point is that we learn to work with these log laws. So now we're going to take some numbers away, and we're going to actually try working with these log laws when we, don't have just numeric values. Oh, sorry, that's just about coming up. First of all, we have one more log law I just forgot about. So for example, in this one, we're going to use the calculator to do some evaluations, or possibly you could do it in your head. For the first one, this is log of 10,000, which would be 4. Okay. And 4 times the log of 10, well, that's just 1. So this would be 4 times 1 is 4. So we could say these two things are the same. Okay. Now, we'll take a look at the next example, log base 2 of 64. Okay. That's the 6th exponent of 2. And log base 2 of 2 is 1, so this is going to be 6 times 1, which is, again, it's also 6. So these two are also equivalent. So if we just go through the table and finish off this pattern here, we'll see they are all the same, and we want to try to recognize the pattern here. So if you haven't already found the pattern, what we're seeing is that if we look at this example here, say 10,000, and we know that's the 4th exponent of 10. So we could rewrite this as log of 10 to the 4. And over here, if we also were to take a look at 64, that's the 6th exponent of 2. So we could rewrite this as log base 2 of 2 to the 6th. Okay. And if I continue going along here, this would be log base 5 of 5 cubed. And this would be log base 7 of 7 squared. So this example it's kind of getting us to the point where we should be able to see that the next step is that we were able to move this to the front when we have an exponent. It's also from an identity that we've already worked with. This is the log in base 5. This is the inverse, the exponential in base 5. So function inverse, that undoes everything, and all I'd be left with was the 3. But anyways, the examples won't always be so simple that we work with that they can just go without a calculator, but the rule will always work, which is the exponent can be moved to the front of the logarithm. Okay, so we'll record that log law. Okay, so here's the rule for the power law of logarithms. One of the ones you need to remember, and again it's loosely connected to the exponents. This is the exponential law, and again there's a multiplication happening in here, just like there's a multiplication happening in here when we raised it to an exponent. So in summary, there's these log laws that you need to know: the multiplication rule, the quotient rule, and the power rule. It's pretty much a guarantee that you're going to have to use these on your provincial exam, your tests, your quizzes, and things like that. So however you choose to know them, hopefully it's because you practiced enough that you remember your log laws. Either way, you're going to need to know them. So let's try working with a mixture of these log laws. In the first example here, I've got try and figure out how can I get this without a calculator down to a number that I want to work with. So first of all, what I should notice in this when I look at it is I can see log base 6 and I can see log base 4. So I'm going to rewrite this so that it's a little easier to see. And I've got log base 4 of 8. Take away log base 4 of 2. So when I combine these, what I'm going to end up with is log base 6 of 54 times 4 using my multiplication rule, plus the log base 4 of 8 divided by 2 using my quotient rule. This will be the log base 6 of 216 plus the log base 4 of 4. So let's see here. This should be the third exponent of 6. 6 cubed is 216. And this would be the first exponent. So it is possible to figure this one out. It is 4. Now, another thing, this one's here just as a reminder because people often forget that the square root, these are like the exponent 1/2. So I'm going to rewrite this as log base 2 of 32 to the 1/2 plus log base 2 of 2 to the 1/2. Okay. Now we just talked about this law, so it should be hopefully fresh in your memory, but maybe you're not quite as confident working with it yet. But this is the law that says we can move the exponential to the front of the log. So this would be 1/2 log base 2 of 32. And of course we could go in the opposite direction. We could take the number that's been multiplied, we could move it back, but in this case it's going to be easier for us to get rid of the square root because that's really what makes it tough to work with these numbers. So log base 2 of 32, that's the fifth exponent. So this will be 1/2 times 5 plus 1/2, and 2 is the first exponent of 2. So this will be 5/2 plus 1/2. So 6 out of 2, which is 3.